Hello everyone, welcome back to our channel. And today we are having this, it's a very unique question, and it says 1 over 3 raised to power x equals to 27 raised to power x minus 4. We are asked to find x. That is a very sweet challenge mathematically. So we are going to see solution. 27 can be rewritten in the terms of 3. That is, the 27 should have a base of 3. And from what we have seen, we are having powers on both sides, so we can think of using the laws of indices to address this. So what do I mean? If we have 3 times 3, that is 9 times 3, that will be 27. It will be 3 raised to power 3. So I'm going to write 27 in terms of 3 raised to power 3. That is number 1. And number 2, we have 3. Anytime you have s, 1 over s is the same thing as the law of indices, s raised to power minus 1. Yes. So let's apply this to this and transform 27 to 3 raised to power 3. So this was C solution. We're going to say from here we have 3 raised to power minus 1 or raised to power x equal to 3 raised to power 3, which is 27 raised to power x minus 4. You see, minus 4, and we're verifying. We're going to do what is needed to be done by ensuring that the bases are the same. But also, if you have from one of the laws of indices, if we have a raised to power m times n, the same thing as a, the base, times n, or raised to power m times n. You see, it could be from here to here, from here to here. For this case, I'm going to use this power minus 1 to work on x, the same here. So I'm going to open up the powers, removing the bracket. So if we do this to this, to be 3 raised to power minus s, minus 1 times s is minus s, equal to 3 times s will be 3s, minus 3 times 4, that is 12. You see this? This is exactly what we want to do. You know why we wanted to bring them to the same base? Because there is a law in indices that says when the bases are equal, therefore the power can be equated. And what we're looking for is found in the power. You see, that is the logic behind using the laws of indices. Now we have the same base of 3, we can therefore equate the powers. How do I mean? I can say minus s from the power here, I'm leaving the base now, equal to 3s minus 12. You see this? And we can continue this from there. And if we are bringing the term that contains s to one side, I will have minus s first. And if this crosses to this side, it will be minus 3s. And to be left with minus 2. Are you seeing that? Yes, minus 2. Don't forget about the minus. So if you do this, we're going to have minus s minus 3s will be minus 4s equals to minus 12. So I'm going to divide through by minus 4 over minus 4 over minus 4. Minus 4 will cancel minus 4 will be left with s. And 4 into 4, 1. Definitely the minus will cancel off. And 4 into 12 we have 3. You see? So s is equal to 3. S is equal to 3. S is equal to 3. And that is our answer. But we can verify this if we are correct. How? Because this value we have s equals to 3 must satisfy the equation. Anyway, we have s, we put 3, the right hand side of the equation must be equal to the left hand side. How do I mean? I'm going to say checking. Let's check. So here we have 1 over 3. Our s is 3 raised to power 3. This is s3 equal to 27 is raised to power 3 minus 4. You see that? raised to the power 3 minus 4. And this is, it could be as 3 raised to the power 3. This is the same thing. And this is, like we know, 27 minus 1. 3 minus 1 is minus 1. 3 minus 4 is minus 1. You see? So, if this is done, 1 raised to the power 3 is 1. All over 3 raised to the power 3 is 27 equals to 27 raised to the power minus 1. And this, of course, is the same thing as this. You see that? Minus 1. We have seen that before. Look at it here. The reciprocal becomes the power. You see that? So, satisfactorily, we have seen that the value of x as 3 has satisfied the equation because the left hand side is exactly equal to the right hand side. Thank you for staying tuned. But before you go, if you gain any value from what you have seen,